Hello everyone, this is Yutao Ma from Primarius Technology. Today we are going to talk about the application-driven open platform for analog and mixed signal design and verification. So first of all, we talk about the challenges designers are facing, and then we will introduce an AI-driven intelligent design platform. After that, we zoom in two major problems we have to deal with. One is circuit simulation, the other is design verification. So when we talk about analog and mixed signal design, people may think about, oh, that's trivial. Analog circuit from I learned in textbook, a few hundred or no more than a few thousand transistor. So it's a small circuit. But actually it is not. Nowadays, the big analog circuit could have millions of transistors, plus the parasitic RC. The element number can be tens or even hundreds of millions in total. So the complexity of the analog circuit increased significantly. That introduced big challenge to EDA tools and also design methodology verification solutions. So we have to enlarge the design platform, the circuit simulator, the physical verification tool, and also all kinds of different analysis verification capability in order to deal with this challenge. Also, as the transistor is shrinking to smaller and smaller, the process variation becomes more and more significant. We have to consider the yield in design those circuits. Also, another important factor is reliability. For automobile applications, we don't want the chip to fail in a few years or even 10 years. For those chips used in airplane or satellite, we expect their lifetime is even longer. So we have to check after 10 years, 20 years, or even 50 years, how the chip's behavior looks like. So we have to do the reliability simulation. Also, the ESD protection, signal integrity, and power integrity, all those problems, circuit check, impose big challenges for analog and mixed signal design and verification. Let's zoom into the memory side. People may think memory are digital circuit, but actually most advanced memory design are using fully custom design flow, similar as analog. They rely on transistor level simulator to do the verification. And such kinds of circuit, when they do full chip verification, circuit size is huge, easily becomes a many million of transistors. On the other side, they require very high accuracy for functional verification, for timing analysis, for leakage current simulation, and power consumption estimation. No matter it's SRAM or DRAM or flash memory, they require both high capacity and very high accuracy. Sometimes there could be hundreds of PVD corners as well. Designer needs to do verification. All those are very big challenge for EDA tools and solutions. Another very important challenge is mixed signal verification. People cannot just split the design into analog and digital part and do the job by themselves. People have to combine them together, use the technologies called co-simulation to deal with the interaction between analog circuit and digital circuit. So designers use transistor level simulators to do SPICE simulation for analog part and use Verilog VHDL logic simulation to deal with the digital part. And then they use co-simulation engine to hook up them together to deal with the interaction between the analog and digital part. Another challenge is ESD simulation verification. Now the chips could have hundreds and even more pins. Each pin has to have the ESD protection circuit. And those ESD protection circuit can also connect it with other part of the design and with each other. So we have to properly model the behavior of the ESD device, do full chip verification simulation of the ESD protection circuit, make sure there's no problem for any combination of the pins of the paths to make sure the ESD protection is comprehensive and reliable. Also, another challenge is the full chip aging analysis. For automobile applications, people have to do the full chip verification to simulate the behavior of the circuit after maybe 10 years, 20 years later. So this has to involve reliability modeling and circuit simulation. Again, it's a big challenge. In order to hook up all those tools used for analog and mixed signal design and verification and provide the user a good platform for schematic, layout design, and optimization, as well as physical verification. So we have to develop a flexible design platform. The design platform Nano Designer provided from Primarius use open access as underlying database. The open access provide comprehensive API functions to allow all kinds of different EDA tools to easily and very fast access to all the different data they required. The design platform got to be very intelligent. So we rely on AI technologies, try to improve analog design flow automation as much as possible, including schematic design, topology selection, transistor sizing, and automatic floor planning, as well as routing. So because the design is huge, and people cannot just rely on their experience and using their hand to do circuit optimization and layout. So that's why we provide such an intelligent design platform using AI technology. Try to help people to do analog and mixed signal design and verification automatically. Also, Primarius provide a full landscape circuit simulation solutions. These include the NanoSpice, the TrueSpice covers analog blocks and also big analog circuit. NanoSpice Pro, which is a FastSPICE to cover the full chip analog SoC memory circuit clock tree applications. We also provide SoC and memory circuit co-simulation solution called NanoSpice MS. All those simulation solutions come with extensive verification capability, including yield analysis, EMR airdrop analysis, signal and power integrity, dynamic and static circuit check, and safe operation area analysis. Also, reliability simulation, and many other functionalities. Let's zoom into a little bit more about NanoSpiceX, which is a very accurate SPICE simulator to deal with analog block and even bigger analog circuits simulation and verification. It has the capability for EMR analysis so that people can just use the same simulator to do the functional verification and also to do the airdrop analysis. It's easy to adopt because it provides compatible format support from both SPICE and Spectre. Another simulator we provide is NanoSpice Pro X, which is accurate and fast, easy to use FastSPICE simulator. In this simulator, we have two simulation engines. One is analog simulation engine for analog part of the design. The other is digital simulation engine for digital part of the design. We can automatically identify the analog part and digital part from the whole design so that apply to different simulation engine and different simulation technologies for different part. In this way, we can ensure the reliable result, accurate simulation result with very fast speed. Also, the mixed signal simulation engine can support the transistor level simulation with Verilog and VHDL type of circuit simulator. Who comes them together to do the simulation? We support our own digital simulator called cosim, also supports the third-party digital logic simulator used in the market. And then the design verification solution got to be very comprehensive. We also provide all those different application-driven design verification solutions. So first, let's talk about the yield. When people talk about the yield, they always think about Monte Carlo simulation for 3 sigma yield analysis. But actually, for different applications, there could be quite different technology used for yield analysis. Very often, the complicated design in advanced technology node, that requires hundreds of PVT analysis. So we developed the fast PVT technology to allow designers to use maybe just tens of simulations to build a model, a machine learning model, to predict the other corner result. And this process is iterative. The model is used to predict, and then some more simulations are done to verify the accuracy of the model, and then, if necessary, improve the model to be more accurate. In this way, we can reduce the total simulation by more than 10 times. Even for traditional Monte Carlo, we developed the fast Monte Carlo technology using different sampling algorithm, different simulation technique to speed up, to get several times speed up versus traditional Monte Carlo simulation. Also, for circuit like SRAM cell, standard cell, they require very high yield, like 6 sigma, even 7 sigma yield. For such kind of application, traditional Monte Carlo won't be able to handle that. So high sigma analysis is used to deal with those high yield problem. Speed up versus traditional Monte Carlo could be thousands or even millions of times. All those yield analysis capability are provided from Primarius yield design solutions. Also for aging analysis, it's also a tough problem, from the measurement to modeling to circuit verification. Because when we do the reliability simulation, we need create accurate and reliability model. And those models need special setup for device behavior measurement. We provide the pulse IV measurement solution to get good reliability measurement data, and based on that, to develop reliability model. And then use our powerful circuit simulator to do the full chip reliability simulation to predict the circuit behavior after 10 years, 20 years, to make sure they can be reliable used in automobile and also like satellites, those applications. So for ESD analysis, we also provide the chip-level HBM ESD analysis platform. We can either take the netlist or directly from the layout, extract the parasitics needed for ESD analysis, and do full chip ESD simulation and verification to make sure all the passes are included between each pin, and also the snapback behavior of the ESD device are well modeled based on our tools so that we can provide designer a reliable full chip ESD verification solution. Thank you for your attention. That's what we provided from Primarius. to deal with analog and mixed signal design challenges, including the circuit simulation and all kinds of different verification solutions. Thank you.